Yo, we're live. Welcome. What's up? Today, I want to work on. Well, let's just move this out of the way so that it's not in your view. Today, I want to work on unit testing my memory allocator implementation from last stream. So, let's look at where we got to last stream and then kind of recap. Oh, more importantly, we need to run this guy so that you guys don't get bored, right? Wouldn't want that. So let's just kind of shove him in the corner here and stick him on top. Okay. So what are we doing? We are implementing unit tests for memory allocator. And that sounds simple at first, but when you look at what is available to us, if I run like cargo test here, won't just give it a sec. 1 second. It's actually gonna get mad, but like there's a lot going on. It's yelling, but the real reason is because the stood crate isn't available, and also the test crate isn't available. And so what we have to do is we have to like implement tests, like a test runner and some test cases that work in like no STD land. And then also on top of that, there's, how do I say this? How do I run them, right? Because right now, when we run our kernel, we do cargo, build, and qemu, and this just like runs some stuff, and when it finishes, we're stuck with this window here. So what would be nice is if one, we could get our build system and test system to like run qemu. Two, we could get it to quit when that finishes, and three, we get some sort of like return code and output from those. So like if I were to just like write out the test output here and then immediately close it, that's not useful. I can't see the results. And so I was kind of looking at like what are my options here, and what we can do is we can implement a UART output for our OS. And what this does is you can output to the serial console, which is just like I don't know if you guys have seen like these like old serial ports sitting in the back of your computer, like COM port. Yeah, like these guys are used. I think they're still on the back of PCs. I'm actually not sure. But basically you can like plug some wires into here and like read them at a specific rate, and you will just like get characters out, like serial protocol. There's probably, or UART protocol. There's probably some pictures here. Yeah, so basically like it wiggles some bits like this. Oh my gosh, where'd it go? And you read them back, and that gets interpreted as characters, and you like pre-negotiate like the rate at which you're gonna wiggle, and like a few other protocol things. You just like punch those in. And so you can ask qemu, the like virtual machine we're running, to implement that protocol and just like forward it to the output of our console. So bing, bang, boom, we'll have like output from our unit tests, and then we can like shut down qemu respectfully after that. So implement a UART output to see output, to see results of tests. Then after we have that, we would want to implement tests generally, which involves like a test runner and test cases, like this, for memory allocator. And then after that, we need a way to like shut down qemu from inside the virtual machine. Easy peasy. So let's the other benefit that this like UART output gives us is it lets us start with some of the stuff that's required for PCI. So based off some of the reading I was doing, I'm not 100% clear on this, but you have like a CPU, and it's got like some like memory lines that go to like the like memory controller, mem, And these same lines also go to like IO. And this like IO expander thing, whatever you're gonna call it, it has like PCI here, which in our world will connect to like network. But it also has serial or UART, we'll call it. I think UART's the protocol, serial is the port or something. I'm not really sure. So what we'll do here is by implementing this, we get testing of some stuff related to this, as well as like initial implementation of this. And that sets us up well nicely for like future stuff. So let's start there, kind of see how it goes. Yeah. So we'll kind of move this guy over here. Bump, 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 bump. And we'll set him to always be on top so that people can see it when they pop in. And we'll new line this. Okay. Cool. So let's just get implementing. So let's go over like off-screen implementation actually. So I've made some changes since the last stream. If I just check my branches here. We got here last time. So if I do this, we can kind of like walk through some of the changes. So one of them was I implemented, I found like a little attribute you can put in your config that says, here, I would like to run my executable, but don't just like call /executable, but like run this for it. So now I can, instead of doing this like cargo build and qemu, I can just type cargo run, bing, bang, boom, I get my output. Pretty sweet. It means I don't have to like keep remembering like my specific qemu command, and also I can like document the qemu command that's running here, which is pretty nice. Where did my other window go? I think it was here. Or did I just lose my div? I did. Okay. So another thing we were looking at last stream was I had this case where I was clobbering memory when I was writing to like the allocated memory segment, and I couldn't really figure out why. And I just like incremented an address randomly, and that seems to like fix the problem. And what I found is, you know, let's see if I can go back to that actually. So that was like here. If I cargo build and obj dump, maybe it was obj dump dash, just no dash, dash x maybe. Okay, here we go. So if I search for like the alloc symbol, which is our base allocator that we're working with in like static memory, this is at address 149.0.0.0.0. And if I just like search for this address a couple times, I actually found that there are multiple things there. So one is the kernel end that we are using to like flag where is the end of our kernel. That's at 149.0.0.0.0. So is the stack top and the kernel. So just like all of these things are sitting in the same place, and so like we're bound to clobber stuff. And so what I did, git diff, check out master, git diff, oh my gosh, git diff. Here we go. So what I did was, in the linker script, if you just like add an empty section, it seems to like increment the pointer. So I think that like what was happening was I was putting this like kernel end thing at the end after my static memory, and it was just like, it wasn't auto incrementing. So I would say like, here, just put some stuff here so that it knows that it has to like go farther than the end of BSS. And that fixed my problem. And when I checked the addresses, they like line up correctly. And if I like change the size of the allocator, then like the location of kernel end updates correctly. So I'm pretty sure that that's right. Just did some like general cleanup of like splitting out functions for the pieces in the allocator. Tried to like make them a little bit smaller, easier to read, and have less how to call this? Less like manual pointer manipulation by like abstracting the behind pointers. It's gonna go well. Stack top was the other one that was colliding, and so I just moved the stack top back 4 bytes. And yeah, that's it. That's all I've done since last stream. So, ready to get into UART implementation. So let's take a look at that. So here we did a off-screen recap. Okay. And can I set wrap here? Set wrap equals word. Can I not? Like, oh, whatever. That's fine. I'll just leave it like that. Okay. So what I want to do here is I probably want to spin up some functions to interact with those I/O ports we were talking about. So I was looking at the OS Dev Wiki, and it looks like they have these functions. So if I go to serial port, I think, OS Dev. If I look at the serial ports, they have an example down here where they initialize it, and they're using these like in B, out B functions. I'm like, what are those? Those aren't defined anywhere. And if I look up OS Dev in B, out B, here they're giving examples of using. These are basically just like, how do I say? They're aliases for these in-out functions in assembly. So, and if I look up the x86 ASM reference, maybe. This isn't the one I was looking at before. Can I just search out? Maybe not this one. This is maybe the one I was looking at? Yeah, here. If I look for out, which is down here somewhere, there's this like out assembly instruction that we can use to write a port, write a value to a port. And so it seems like we'll need to implement these like in-out functions in order to interact with the serial device provided by qemu. So I think first we need to implement those, and I don't really have any way of testing those other than just implementing the rest of serial. So probably what I'll do is I'll just copy paste this initialization, try to run it, and then see where that ends up. So let's split out a new file. Maybe we split out a whole new module called like IO. So let's do that, because in IO we can then start working with like, we can put these like in-out functions at the beginning and then add like serial underneath or something. So we'll make dir IO, and then we'll edit IO or source IO mod. And here's where we'll define everything for now. But later, these will be split out into separate functions or separate files, I'm sure. So let's start just rustifying this. So we'll do const port U16 is this, right? Then we convert this to a function. So this is pub function in its serial, and this returns an I32. Here, we need to define in B and out B. So we'll do, oopsies, pub function, or we'll say function in B. This is unimplemented, and this returns probably a U8 and takes in an address, which is a U16. And out B is the same, so it takes in an adder and value, and returns a U8. Nope, it returns nothing, sorry. And this is also unimplemented. Now we want to look at our main, and we want to initialize this probably pretty early. So let's add the IO mod. And then in main, we will call this IO function, which was init serial. And we'll see what happens. This is IO init serial. So now if I go run, which I can do now, it's going to start getting mad at me for some missing semicolons and stuff. Easy peasy. Okay. Nice, so I'm getting the not implemented in init serial. So here, I think I can just do some inline assembly where I call out B. Again, I used the ATT syntax in my first in the first thing I worked with, so now I'm just using that all the time. raw string should be terminated with this. So I got like this. Okay. And I guess these don't, maybe these have to be raw strings. So out B, so let's look at the inline assembly syntax for Rust. Inline assembly. Okay, so I can put in like named variables. So let's just do, we'll do out B is this goes in out in ATT syntax. So this is probably val. This is probably port. Cannot find macro ASM in the scope, so this is probably use core arch ASM. No argument in port, so now I just do port equals port. And so what is this trailing thing here? And I just set if this is like a register, and I probably want to specify like a specific register. So in reg expr, the allocated register will contain the value of expr. Right, okay, so I say port equals in, and here can I specify a specific register? Because if I remember correctly, the port needs to specifically be in DX, right? So here I can specify DX as a reg. So in DX, and this is going to contain the value of adder, right? Invalid class DX. So maybe I have to say like reg DX or something. Oh, like this. X equals in out reg X. Port equals in reg. Okay, is this valid syntax? Okay, and then val equals in reg val. Is that right? I can out immediate AL. So output byte in AL. So these, yeah, so I need A to use A no matter what. So how do I specify which registers? Let's see. So same as in, okay, out, in. In is what I want. Int reg can refer to a register class or an explicit register. The allocated register name is substituted into the ASM template string. The allocated register will contain the value of expr at the start of ASM code. The allocated must contain the same value at the end of ASM code, except if a late out is allocated to the same register. Okay. So here, I should be able to say port comes in DX and val comes in AX, but AX is an unknown register class. So what am I missing? Because down here, oh, here they're saying if I put in the class register, it could be any of these. But here I could put in reg ABCD, so reg D, is that what they mean? ABCD. Can I specify like which specific register I want? Because I need to here, right? Like, yeah, I'm missing something. Register operands. Explicit registers are explicit through string literals, while registers are explicit as identifiers. Oh, so here I can just say DX. Explicit register arguments cannot have names. Aha! So I wonder why I have to specify DX like this. But that's okay. And so now I can do the same thing for this. AL, this. there's no argument port, so now I just do %dx %al like this. But maybe I reverse them because I'm an ATT syntax. It turns out that I do just have to learn them both anyways, but whatever. Okay. And then here we want to do the same thing for in B. Which is going to be alphabetical A, B, C, F, G, H, I, J, K, H, I, J here, in. And so here they're going to do port into AL, or I can do it into EAX. But this is only for double word. Oh, no, okay, so this is always A, which is the return register. I feel like there's a rule for inventing ASM syntax when you have to throw a dice to someone that's source dest or dest. Dude, it is. And it's just if you have like AT&T syntax or Intel syntax. Let's see if we can find it. Come on, DuckDuckGo. It's just like some people like here, like move EAX5 versus move 5 EAX, right? It's like, there's other subtleties too, like the $sign versus not $sign. I actually spent like an hour a couple days ago because I read something in Intel syntax and then tried to like use it in AT&T syntax, and I thought that I could just write the number 5. But it turns out in AT&T, that's an address. So I actually ended up like reading the memory from a location instead of putting an immediate value there, which is like, oh. But yeah, I think it is. You just have to be like very careful. And I actually don't know if this is in Intel or AT&T. So I'm just kind of guessing based off the convention that AT&T goes source dest versus dest source. But I fully expect this to like fall over. So sorry, this was the, where was I? I was implementing in. Oh, and I think that this out B is wrong, but we'll see. Maybe I can just call it out. So now in B is the same thing where we read from port. So the source is port and the dest is AL. And this guy has nothing in him at first. And then can I return that? Like if I go like U8 ret, or sorry, let ret U8 equals ret is 0 U8. And then here I put this in ret and then return ret. Does this do what I want? Let's quickly glance at this again. So out reg expression. Xvar must be a possibly uninitialized place expression to which the contents of the allocated register are written at the end of the ASP code. Okay. So let's see if this does something. Cargo run. Unnecessary braces. I put a capital U on use by mistake. Okay. Cannot assign twice the same variable. Oh my gosh, you're such a whiner. And we have to make all these functions unsafe because we're writing inline assembly. Value assigned to ret is never read. Okay, let's try this. Invalid operand for instruction. Oh, this is in. Okay, so that ran something, and now can I like try writing to the terminal and seeing if I see anything? We'll just copy paste this write serial, and we'll just try calling this. So, oh, let's check the return code of this actually. Let's make sure that this is working correctly. So assert equal init serial 0. Hey, that's pretty cool. So it did something. And let's just sanity check the IO implementation and like change the address here to something else. So com1, do they have something like about like where do I write, where are the addresses of these? Let's try changing this to com2. Nice. Okay. So that's a really good indication that like this like copy pasted code that I don't understand yet is doing the right thing. But more importantly, it means that my like implementations of in B and out B are doing what I expect. Well, it doesn't mean that, but it's like a really good indicator. So now what's next? What's next? Now we try to write something to the console and see if we can split it out. So this is implement in out to IO ports. This is done. And this is, then we want to write to console like this. Okay, so yeah, let's try write to console. So what do they say to do here? They have these functions that we're just gonna yoink blindly and see what they do and convert them into Rust. So this is which is a U8, and this returns nothing. And here I think I need to do this and remove these brackets. And this would return a U8 actually. And make these unsafe. Function write serials never used, blah, blah, blah. Okay. Okay, so now I should just be able to, at the end, write serial an A. And let's see if we get like an A on the serial output. So let's cargo run. So I don't see anything there, but maybe I need to adjust my qemu command. So here we had this guy, and what if I just start punching in like, I think it was serial STIO or something? Hey! There we go. I see it there. That's shocking, actually. I expected this to be a lot more of a pain in the ass. So let's start B, C, D, E, F, new line. Nice! Look at that. Look at that. It's easy. Man, I thought that was gonna take a lot longer. So that's a nice little surprise there. Okay, so I have my serial console, and it's writing to the console, and so that's shockingly done already. So now what I want to do is abstract println. So right now, I have this like print macro that just like unconditionally writes to the like VGA window popped open by qemu. So when I like cargo run, all of this stuff, it's just like unconditionally put here. And so it'd be kind of nice if I could choose to like print to the terminal or to like the serial console or to the VGA buffer. You kind of get some stuff for free here. If I just always output to the console and don't really worry about the VGA buffer, then I get like scroll back and shit for free. Do I want to worry about like is that fair? Maybe not. And it's like kind of a lot less exciting to say I'm like writing my own OS and just like run a program in the terminal. There's something like satisfying about seeing it pop up in qemu. But for now, I think I'm okay with just maybe I'll make serial the default for now. So or maybe I'll write to both. Yeah, let's write to both. That seems fair. So let's just quickly make a new branch that says like, I don't know, UART sample, UART implementation. And in here, let's add what we've done so far and say, UART can write to screen. And then let's maybe like rustify this, like put some stuff where it belongs, and then put this println macro in the right spot to print to UART and VGA. Nice, nice, nice. Okay, so the first thing that's going to have to be done is this VGA. VGA is technically I/O, so we'll put this in here. Then we probably have to mod VGA and maybe pub mod VGA. And probably put this at the very tippy top. Or do I put it after uses usually? I don't know. Doesn't really matter. Then I probably want to, in main, do this. And in IO, also do this. Macro use to get the like macros populated up. Println macro bubbled up. And here I need to use IO VGA terminal writer, and I think that's everything. Nope, it doesn't like that. Consider importing this module. I wonder if in my IO module to get the print line all the way out, I have to do like pub use VGA print line or something. Like, to get these bubbled up. Pub use. No print line in IO VGA. That's annoying. I guess what I can just do for now is just move these macros up one. So IO, just drop these guys here. And I think, oh, oops. I think that maybe it was actually fine the way it was, and I just didn't read the errors right. Let's double check that. Yeah, just unresolved import. Oopsies. So this should be create IO VGA. Okay, whoopsies. Cargo run. Still not happy. What doesn't it like? Create VGA unresolved import. Here as well. There we go. There we go. Okay, sweet. So the print line's bubbled up. We've moved some stuff around. VGA is now in the IO module, and everything's still running correctly. So we're happy there. And now let's in the IO mod, maybe let's think about this. So maybe what would be kind of nice is if I could like have some function that's like function write to standard out or something, and this takes like a string. And what would be nice is if I could like iterate over the different outputs and like write to them. Or, well, okay, so I was gonna say I could like make a trait and like say that I could write to both of them in the same way. So I could say like for available writer, for like I could say like for writer in available writers or something, and then do like writer.write s or something. And I was gonna be like, well, I can implement some trait and then like keep them all in here, but I don't really have to do that. Because it's simple enough that I can just iterate them manually. So let's start with, maybe we split out this like serial stuff into its own module here. So we'll do source IO serial, and we'll like make a struct serial, and we will use this from here so it gets imported, and here we'll just rip this stuff out and move it into the serial function with the serial module. And these are now like implementation details of this serial struct. I guess I was initially thinking that like there's memory associated with this, but there really isn't, huh? There's like these being free functions is actually like totally fine. So let's just leave them as free functions. Okay, so we'll call this init, and oops, I've missed a const that I need. There we go. use create IO. What is it? In B, out B. Okay. And then let's just make a like pub function write. Yeah, we'll just call it write here because it's in the serial mod. So we'll have like serial colon write. This will be serial colon init. And in this, we'll take in a string. And here we'll say for, I guess we have like the same thing that we had in the VGA writer, where we take the thing as bytes and we write it. So we can say for b in s dot as bytes, then we just say write serial b. Easy. We dereference because Rust is getting mad. He's mad because it's unsafe. Do I want to just like when I do this, I often just like shove an unsafe on the beginning of the function. But I wonder if that's unreasonable. Like somewhere we have to claim that it's safe. And it's reasonable here to assume that the serial port is available after it's been initialized. So maybe that's part of this is... No, even then, it's still safe. It just won't do anything. And so you could, like, argue that you should, like, force some API, like, force constraints that, like, make you initialize this with the type system, right? You could make a struct called serial that you can only get by calling init. Which isn't, like, super unreasonable. And then you could argue that, like, every time you write to it, it is safe, assuming that nobody else clobbered you. But we don't have to get that crazy because this is an OS only for me, and so like adding all this like type system stuff to force me to be safe is like I don't really care. So I'm just gonna drop unsafe everywhere for now. Just kidding. I'm gonna put the unsafe in here. We can use write to console from it doesn't fucking matter. Whatever. This is easier. Okay. So now in IO, let's like pull this like VGA printer macros, and let's like pull these into the IO module, like this. And now we can just also write the same thing to serial. So we can do this where we write for format and we take in the format args generated by like the Rust macro that does formatting for us. I think it's format args, like this. And he returns a format argument. So for format arguments, and these are tied to like some lifetime that I don't care about. By reference, maybe. Nah. Let's take them by value and we'll see what happens. So then we can pull out, we can like iterate over these probably. Ooh, now that I have allocation, I can actually just make these two string. That's kind of fun. Or I could try to like implement format write and do the same write macro as before. That's probably easier. So just for the sake of being able to use this like write macro, I am actually gonna make this a struct. So we'll say struct serial, init returns result serial init error. We make an enum serial init error. like this, and here we'll just return okay serial or error serial init error. And I was going to make this an enum that has like multiple failure types, but there's only one way this can fail, so we can just return it like this. Pub struct serial init error. And now we can implement core format write for serial. This can be part of the serial implementation. And we'll, instead of calling this init, we'll call this new to match conventions. And now we will copy the VGA implementation here. Like this. And we'll just do this. Boom, 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 boom. Okay. And shove this in unsafe. We have to do the same thing as we did before, actually, where we have a where we have like a static reference to it. We'll say static serial is a type of type serial, and it's equal to serial new, which is a private function. We'll just say that you have to initialize. This will return nothing. Like this. And we can actually just do like this. We don't really care. Okay. So now in the IO implementation, we can probably just do the same thing here, where we say fail to print to serial. And here we can do the same thing where we say IO serial serial. And here we do the same thing. Create IO. And like this. Okay. And I think that's it. So now if I run this, do I get output? No, because we have to run here. We have to do IO serial init dot expect failed to initialize serial. Okay. And in here, you're supposed to derive debug. And we're close. Here we do the same thing where we say we don't actually need self here, so we can do it like this. Okay, so it succeeded to initialize, but we still didn't get any output here in println. For println, which is kind of surprising. So let's printing. I know this is like recursive, but I just want to see if it does something. Can I do like IO? Create IO println. So probably in mod, these macros need to come before mods. And then in the serial device, I can now take out this prefix like this. Okay. So we do in fact say that we're printing. So we are calling this. And this is just like write serial. Is it not happening? Like, right, like when I did this, that worked. Oh, it's because I'm an idiot. So in my arguments to qemu, I have to say that I want standard input output. So that's in cargo config, and here I just need to say console standard input output. Now when I cargo run, console isn't it. What was it? stdio serial equals stdio. Sorry. So I go back into cargo config and replace console here with serial. Cargo run. Here we go. That's sick. Oh, very, very nice. Okay, so now when I print, I get the output of both serial and the VGA. And so now I probably, where is this? Cargo, in cargo config, I can probably just say like, I don't really care about getting that window open anymore. Oh, so why doesn't that work? Maybe no graphic implies serial stdio. Yeah, okay. Nice. I can't quit it. Okay, there we go. So maybe I like that. Maybe I don't. I think I don't. So let's do it this way. We'll leave this the way it was. So it was serial stdio. And we'll still let the window pop up. But we'll just get the output here later as well so we can copy paste. That's a fine implementation for now, I think. I'm happy with that. So we'll say get status, get add dot, get commit, and we'll say println now goes to console as well as VGA. All right. So we'll call this done. And now what we want to do is we need to shut down qemu inside the VM. So I read somewhere in this like what's it called? Rust OS, I think. I think I saw some writing an OS in Rust. This is what I was looking for. And in here, he said that there's like a way to like ask qemu to exit. So ISA debug exit device. So let's see what that is. qemu. Oh, I don't really want to like cheat too much by like reading someone else's implementation. So this is qemu itself. I think it's fair to read the qemu source code. And what is this? So this doesn't really tell me much. Let's go back to this. Okay, so there's probably, it looks like there's like an exit device on IO port x64, and you can just write the exit code. Oh, that's really slick. So after I run my main, I could just exit one. Okay, so let's try this. So we don't have anything other than this that we need to copy. So well, I guess this is technically IO, even though it isn't really, and we'll call this like unsaved function. What's the like, is it just exit? The normal libc would do this. Man3 exit maybe? Yeah, okay. So we'll just call it that. Exit, and we'll call this code I32. And there's a ISA debug exit port is this. And I think we just do be like out B ISA debug exit port. Like, I think they said, I think I saw in that doc that for some reason they have failed and success as one prefix. Do they explain why? Oh, they want like, okay, they want like success. No, I'm just gonna export the code. I ignore his recommendations. And I guess we'll make this take a U8. And at main, we'll call exit 0. This. This. There we go. And we have to make this public. Just pub unsafe function. And now, if I run... Oh, oops. I have to enable the device. So how did he say to do that? He said... Where'd it go? Here we go. Using the exit device. Where'd it go? Where'd it go? Ah. So let's just go back here to cargo config and just drop these arguments that he said to put in here. Oh, I see. So I actually could define this to be whatever I want. Hey! There we go. It did exit 1, which I don't like. So let's try exiting like 3. Oh, so it is, in fact, doing something funny, like he said. So 3 shifted left 1 is 7, is that right? Okay, let's see what this guy wrote about this. Success exit code. Boot. Oh, that's so boring. That maps specified code to exit 0. I don't care about your boot image stuff. I'm running my own thing. For example, using exit code 0 for success is not a good idea because it becomes 0 shifted 1 or 1 equals 1 after the transformation. So how do I... How do I define the exit code for within? Oh, so he's saying that he wrote this wrapper that calls qemu and maps it back. So he's basically saying that there's no way to get qemu to exit code 0. So let's see if that's true. I say debug exit error code. I guess I could look at the implementation here. So I should see that like 1 shifted 1. Debug exit right. Exit here. Val shifted 1 or 1. Oh, that's so annoying. Why are they doing this to me? So I do just have to like wrap the qemu call in like a test runner. But that's like fine. It doesn't really matter. We can get away with that. Yeah, that's fine. We'll make it work for now. So shut down qemu from inside the VM, and we'll say and return error code. Very nice, very nice, very nice, very nice. I'm happy with that for now, and let's start trying to implement any testing framework, I guess. Okay. So we can get a lot closer now if I say cargo test. It's still going to get mad, but I think that there was a feature somewhere that's like a test runner. Custom test frameworks. Here we go. So here we have a custom test runner, my runner. And what happens if I do that? Custom test, so I have to enable the feature, which is feature custom test frameworks like this. Now we're on cargo test. It won't be able to find my runner, so we'll say kernel main is just what we'll call. And now it's just really unhappy for all of these duplicated symbols. So maybe I have to like block this under config test or something. The first is defined in the core crate. Second definition is core, loaded from both these. So why am I loading both of these? Does this happen if I completely rebuild? Is there like some caching problem? Let's see. Cargo test. Okay. Duplicate lang item. Cargo tests, custom test frameworks. Oh, I think I actually saw something. Panic equals abort. There is currently bugged duplicate lang items. Yep. Try moving it, then cargo test. Okay, but then how come? Like, we needed this panic abort because we don't have unwinding, right? So does he remove that somewhere? Let's see. Does he just remove it in the test definition? We need to change the name. This function is nor because there's no main, blah, blah, blah. Sure. Oh, maybe I should be using the no main attribute. Oh, I am. We don't need these to be commented. So I don't really understand how I'm supposed to use this. Oh, okay, so here we actually need like a test main as well because it doesn't like the how do I call this? The arguments of kernel main. So let's just make a function test main and see what it complains about now. Function takes zero arguments once was supplied. So I think that this takes like a list of functions like this is what this guy said. Right, and we'll call this test functions is this list of test functions. Okay. So we're getting close. Now, when we launch and we're in test mode, the test failed to rerun past bin kernel. Okay. Process didn't exit successfully. Yeah. So the problem is that we're like unconditionally jumping to the kernel main from our bootstrapper. But when we're in test mode, we don't want to do that. So I think what I saw here is he just called test main in that case. Something different than main through the re-export test harness main. Okay. if you say so. Yeah, I mean, I don't really understand why I have to do that yet, but we'll find out. So here he just says config test. And can I just like apply that to this block and say like test main? But I need to pass in the functions. Ah, okay. So I see. So we have to create a test runner, right? And then we have to say that when we call the executable, it's called with no arguments, or maybe some arguments, not really sure there. And it like collects the tests and runs them through this test runner. But how are we going to do that? How do I say this? We don't have that here. But if we say, hey, can you like make that a callable function, then we'll call that and it will call our test runner. Okay. Yeah. Okay, so now it's like actually doing something. Okay. Yeah. This is getting really good. And so now the only thing that's happening is like we're getting through all of main. So here we should just return 0. Very nice. And then we can move this IO exit stuff up here, right? And do something like this. Yeah. Okay. And then all we have to do is figure out a way to make it so that cargo doesn't get mad. And probably we also need to like do this, right? So that if we panic, we exit uncleanly. I'm not sure. I don't actually know. Almost certainly yes. Okay, so we've got enough out of this guy. We don't need to reference him anymore. And now let's look at like converting those exit codes back. So we'll make a wrapper script. We'll call this qemu wrapper. And this will be a bash script that calls those qemu args that we were using. So in config, what is this? In .cargo config, we have this script that we're running. And we'll just put this here. And we will pass in the kernel. And then our runner will now just be qemu wrapper, like this. That seems reasonable. And we will exit what they returned shifted right by 1. Which maybe they'll just let me do. Cargo run. Okay. Right, so I didn't name it right. That's cargo config, and this is qemu wrapper.sh, and that's not executable, so I have to make it executable. And now if I cargo run, it still doesn't like that. So qemu wrapper sh cannot execute, required file not found, target debug kernel, cannot execute, required file not found. So what did I do wrong here? User bin, oh, oops. There we go. So syntax error here. What's like the bash syntax to like shift, right shift? Bash syntax bit shift. Bitwise shift integer. That's what I thought. Okay, that's what I thought it did. $? Okay, mvim wrapper. qemu wrapper. Oh, I forgot the $. God damn it. Okay, so now let's try writing a few error codes and see if they pop out the way I expect. So we'll call IO exit 0 and call cargo run. Nice, that's 0, and we'll call IO exit 3. Okay. Okay, cool. So this is working now as I want it to. And now cargo test also working as I want it to. And so now all I need to do is here after panic IO exit 1 loop, and we'll call this unsafe. So now if I say like assert EQ 10, we see left, right failed and a positive error code. Let's go. Okay. So we now have our test runner set up. So we'll call git add dot and say git commit -m test execution or cargo test works ish. We actually haven't run any tests, so we can't tell. So let's actually like make a test here and check it. So let's go into like let's just do one main, and we'll say mod tests, and we'll gate this with config test, and we'll add a test case, and we'll just say assert false cargo test. So nothing happened there because we're not running the function. So for test function in test functions, test function. Okay, so that failed, and now I wonder if I can like get the name of the test. I think I saw him do that in this as well. So he managed to get the name. So, oh, he just prints. He does the input output in the test itself. Yeah, okay, that's like pretty reasonable. I can get behind that. And if I have like multiple tests, I guess asserting here is actually wrong, right? Because it actually like blocks the other tests from running. Right, if I do like this, or how do I do this? Like this, print test 2. Right, like we don't actually get the output of all tests, but maybe that's like okay for now, right? Like even if we don't run all the tests, we'll just like fix them one at a time and they'll fix themselves. I wonder what would be cool is if I could like catch the panic and fix it. But because of the like panic abort strategy, that won't work. We also did turn off panic abort for some reason. Which means that it might like try to unwind the stack. Not really sure. Not really sure. Okay. Unfortunately, I'm short on time today. So I'm going to call it there. We didn't actually implement any tests, but we got like to a pretty good spot where we like can start writing tests. And I think that that's exciting and cool. We also got like serial output. We got, here, let's like pop this guy open. So we got UART working, which is very cool, which means that like we can like print to the screen and like catch the output later. We have the ability to shut down qemu and return an exit code, which means that if we like had a set of tests that all passed, like this, like let's do, if we ran in here and we just like let all of these work, I think that means if I ran cargo test, right? We get test output and it closes qemu, we get return 0, and like it looks to the system like it works. And that means that like if we wanted to put this in our linter script to say like make sure that all your tests pass before you commit, then like that will work and we can like return the correct things to the operating system. Bing bang boom. And then we like set up the test main, and all of that's like working now. So that's very cool, very cool. Next stream, tomorrow probably, we can start looking at like actually writing some tests for the allocator, making sure that they work in release, figuring out like why this panic abort isn't doing what we expect. Like see if there's like a way to make panic behave a little more sanely. And then get into like PCI implementation. So very cool. Thanks for watching. Catch you guys in the next one. Bye.